Okay, so what I've found the best way to sort of share or to show how to do these problems is to kind of do it in Zoom this way and then sort of draw it all out and with my cursor show you what's going on. So hopefully you've all read the problem about phenylketonuria. I won't go through and read the whole thing again. So if you haven't read it, pause right now and then go back and read this problem from the PowerPoint. So to begin with, what we always want to do first is to draw out exactly what is going on. Okay, so it's telling us up above that phenylketonuria is caused by a recessive allele, little k. PKU stands for phenylketonuria. So when you have a genotype that is little k, you are affected. When you have at least one allele that is big K, you're going to be wild type. So in this particular problem, you have an individual that's big K little k mating with another individual that's big K little k, and they're going to have a family of 5. So over here, I've said number in the family of children equals 5. Or if we draw it out as events, these are 5 separate independent events, having the first child, second child, et cetera, all the way down to the 5th child. So in part A, it asks, what is the chance that all of their children will be unaffected? Okay, so here we have the 5 events, 1, 2, 3, 4, 5. Underneath each of those, I write down the U so that we know that we're looking at unaffected children, right? And then these are 5 independent events. So in order to figure out the total probability of that, we just have to figure out the probability of event 1, event 2, event 3, event 4, and event 5, and then times them all together, because it's if event 1 happens and event 2 happens. So in here, and we know we're going to multiply. So to figure out the probability of any individual child being unaffected, we can draw a Punnett square over here, big K, little k, draw them all out. 3 of the results, big K, or the heterozygous individuals are going to be wild type phenotype. So the probability of being unaffected, so unaffected here is essentially the wild type phenotype, is 3/4. The probability of having PKU is 1/4. So here we go back and we put 3/4 because U equals 3/4, right? So 3/4 into all 5 different events. That's the same thing as 3/4 raised to the 5th power. Times those all out and you will get 243 over 1024. That's the probability that a family of 5, with these 2 individuals, if they have a family of 5, that all 5 children will be unaffected. Okay, so part B is what is the probability that 4 children will be unaffected and 1 will be affected. So again, we can write out the 5 events: unaffected, affected. Now the only thing that changes is we have an A instead of the U, right? Well, one of the things that changes is we have an A instead of a U. U being unaffected is equal to 3/4. A being affected is equal to 1/4. So you're going to times those all together, just like we did above, and you come up, the result is 81 over 1024. However, in this one, it's just asking you what is the probability if 1 is affected, right? And as you can see here, say this is the first child over here, this is the youngest child over here. You could have the youngest child being affected. You could have the second to the youngest child being affected, et cetera, et cetera. You just have to have one of those. And so you can have a bunch of different combinations. So when we do combinations, we use that formula, the factorial, and that is set up as n factorial over x factorial times y factorial. So in this case, 5, you have 5 different events. So that means you have 5 factorial here on top. On the bottom, x factorial, we'll just call x u. It doesn't really matter, but that is 4 factorial because there's 4 u's, and then 1 factorial because there's 1 affected. Here, you times that out. 5 is equal to 5 times 4 factorial. 4 factorial is the same thing as 4 factorial times 1. The 4 factorials cancel out, and so there's 5 different combinations. You can see that over here. You can have either the first or the second or the third or the fourth or the fifth different combinations of that. and all of those would satisfy that one child is affected of the 5. And so then you just times that by your total probability, you come up with 405 over 1024. Okay, for C, it asks you what is the probability that at least 3 are affected. So when they say at least 3 affected, we can think of that as 3 being affected, or 4 being affected, or 5 being affected. In all 3 of those accounts, at least 3 are affected. The lucky thing here is that we've already calculated the probability for 4 being affected in B, and all 5 being affected in A. So all we really have to do is figure out what's the probability of 3 being affected, and then add it to our other 2 results. And so here we have the 5 different events, 3 unaffected, 2 affected. We times those out. That equals 27 over 1024. But here again, we're going to have different combinations. So we have to figure in the combinations. N factorial is still 5 factorial. And then X factorial is 3 factorial. Y factorial is 2 factorial. You sort of tease that out as 5 times 4 times 3 factorial. That's the same thing as 5 factorial. And 3 factorial times 2. 2 is the same as 2 factorial. You get the 3 factorials to cancel out. That equals 5 times 4 equals 20, divided by 2 equals 10, times 10 by your previous result. That gives you 270 over 1024. So this is the probability that 3 are affected. So probability that 3 are affected, or 4 are affected, or 5 are affected, you add up each of those, and the total equals 918 over 1024. The last one is actually probably the easiest one, right? It asks you what is the chance of the first child being unaffected. So since these are independent events, you just have to worry about, okay, what is the probability of the first child being unaffected and a girl? So it's really, there's 2 events that have to happen. You have to have the birth of the first child being unaffected. You know, that's a probability of 3/4. And the birth of the first child being a female. We know that the probability of being a female is 1/2. You just times those 2 together, and that equals 3/4. Okay, so there you have it. Let's see if I can stop this video. Here we go.